Right now, a mysterious object from interstellar space is approaching its most critical phase, and we can't even see it. Yesterday on October 29, 2025, and 3I Atlas, the third confirmed object from another star system to enter our solar system, has reached a turning point. At exactly 7:47 a.m. Eastern Time, 3I Atlas reached perihelion, its closest approach to the Sun, coming just 203 million kilometers from it. But here's the cosmic irony. At this very moment, when astronomers need to observe it the most, 3I Atlas is completely hidden behind the Sun from Earth's perspective. Our most powerful telescopes and radar systems can't see through the blinding solar light. It's as if the universe is shielding the event on purpose, creating a moment of mystery at the precise time of greatest importance. This fast-moving, unusually large object already displayed a set of behaviors that defy what we know about natural celestial bodies. And now, during the most revealing moment in its journey, it's disappeared from view. What's happening behind the Sun could change how we see the universe forever. Perihelion isn't just a milestone on a cosmic map. It's a moment of physical transformation. As a comet orbits closer to the Sun, the intense heat and radiation cause dramatic chemical and physical reactions. Ice is turned to vapor, jets erupt, tails form and shift, fragments sometimes break off. For most comets, this is when they reveal their secrets. It's the moment we watch for, measure, analyze, and learn. But in the case of 3I Atlas, we're blind. Because it passed directly behind the Sun from our vantage point, its approach to perihelion occurred in complete visual isolation. Ground-based telescopes are overwhelmed by the solar glare. Space telescopes are either not positioned to see it or are in safe mode due to proximity to the Sun. This event, the most critical moment in 3I Atlas' journey, is essentially happening in a cosmic blackout. And that silence is eerie. What's more, the solar intensity it's experiencing right now is about 770 watts per square meter. That's enough to trigger massive transformations. If this were an ordinary comet, the surface could be fragmenting. The internal structure could be cracking. The tail might be blooming into a spectacular fan of dust and gas. Radar is our fallback when vision fails. If we can't see an object in space, we try to bounce radio waves off it. This is how we've measured the shapes and spin rates of asteroids, even when they were too dim or too close to the Sun for visual observation. But in the case of 3I Atlas, radar also let us down, not due to technology, but timing. At its closest approach to the Sun, 3I Atlas is still 269 million kilometers away from Earth. That's simply too far for radar systems like Goldstone or Green Bank to detect a faint, fast-moving object with precision. Had this moment occurred when Earth was on the other side of its orbit, about 6 months earlier or later, we would have been just 54 million kilometers away. That's within ideal radar range. At that distance, we could have gotten measurements of its size, spin axis, rotation rate, surface texture, even hints about its density. Maybe even metallic surfaces. Instead, we're left with silence and a cosmic what-if hanging in the air. Even though our telescopes are blinded and radar is out of reach, the search hasn't stopped. Radio astronomers across the globe are now sweeping the region of the sky where 3I Atlas is expected to reappear. They're listening for unusual transmissions, anything narrowband, pulsed, or artificial sounding. These aren't random stabs in the dark. They're targeted efforts based on the theory that if 3I Atlas were technological, it might emit signals or even drop probes during its solar passage. International networks are also analyzing infrared wavelengths, trying to spot unnatural heat signatures, something a propulsion system might leave behind. And back on Earth, political pressure is mounting. Congresswoman Anna Paulina Luna recently demanded the public release of high-resolution images from October 2, 2025. Images reportedly captured by U.S. military satellites tracking deep space objects. If those frames contain visual anomalies, unexpected flares, maneuvering lights, or shifts in trajectory, it could validate growing suspicions. Every hour now, scientists are watching, waiting, and analyzing incoming data. The question isn't just what 3I Atlas is doing, it's what it might become. To understand why this moment matters, we need to understand what 3I Atlas is and why it stands apart. This is only the third confirmed interstellar object ever discovered entering our solar system. The first, 1L Oumuamua, stunned scientists in 2017 with its cigar-like shape, tumbling motion, and lack of a visible tail. The second, 2I Borisov, looked more like a traditional comet, but still carried interstellar dust signatures. But 3I Atlas is in a league of its own. Estimated to be nearly 5 kilometers wide, it dwarfs Oumuamua by volume more than 200 times. That makes it not just a visitor, but a juggernaut. If it were to impact Earth, it would release over 1 million megans of energy. Thankfully, it won't come anywhere near us. What's more intriguing is its speed. Combined with its mass, its kinetic energy is off the charts, tens of millions of times greater than the energy released by the atomic bombs at Hiroshima and Nagasaki. Harvard astrophysicist Ava Loeb has developed a classification system for space anomalies called the Lobo scale. It measures how likely an object is to be of technological rather than natural origin. 3I Atlas scores a 4, suspicious, possibly artificial. Why? Because it's displaying 8 key anomalies that, when considered together, make the odds of it being a natural object staggeringly low. 1. Trajectory alignment. Its path is almost perfectly aligned with the ecliptic plane, the flat disk where most of the planets orbit. The odds of a random interstellar object arriving within 5 degrees of this plane are just 0.2%. It's as if it was aimed. 2. The anti-solar jet. In mid-2025, astronomers observed a jet of material being ejected, not away from the sun, as all comets do, but toward it. This violates known cometary physics. Nothing in natural solar heating explains it. 3. Velocity and mass. 3I Atlas combines unusually high speed with a massive body, far outside the range of typical solar system objects. The odds of this combination occurring by chance, less than 0.1%. 4. Perfect timing and Earth invisibility. Its perihelion not only occurs behind the sun, but during a time when Earth can't see it. The odds of both conditions aligning so perfectly are 0.005%. It's as if it chose the one moment we couldn't watch. 5. Nickel-rich composition. Spectral analysis reveals a gas cloud rich in nickel, but poor in iron. That's strange because natural bodies usually contain more iron than nickel. Industrial processes on Earth, however, reverse that ratio. 6. Low water content. 3I Atlas contains less than 4% water ice, remarkably low for a comet. Most comets are up to 80% water, so what's fueling its tail? What's sublimating off its surface? 7. Extreme negative polarization. The way 3I Atlas reflects polarized light is unlike anything seen in comets or asteroids. It's an optical signature with no match in nature. 8. Direction of origin. Its inbound trajectory aligns within 9 degrees of the WOW signal received in 1977, a famous unexplained radio burst many believe may have been of intelligent origin. The probability of that alignment is just 0.6%. Each of these anomalies might be explainable on their own, but when combined, the cumulative probability of all 8 occurring by chance is less than 1 in 10 quadrillion. That's not coincidence. That's a message in numbers. If 3I Atlas is more than a comet, if it's artificial, this perihelion moment might trigger behavior that reveals its true nature. Scientists are now watching for changes in speed or direction that defy gravity, sudden increases in brightness with unnatural profiles, emission of narrowband radio signals not typical of space objects, separation of smaller probes or modules, infrared heat flares suggestive of engine activity. Alternatively, if it's a natural body, we should expect to see more traditional cometary behavior, a brightening tail, fragmentation due to solar stress, or jets expanding radially from the nucleus. But here's the catch. We won't know until it emerges from behind the sun, possibly days or even weeks later. If even one of the anomalies observed so far points toward artificial design, the implications are historic. It would mean that intelligent life has not only existed beyond Earth, but has engineered something capable of traveling across the stars and entering other solar systems. It would raise enormous questions. Why did it come here? Is it observing us or simply passing by? What technology could survive such a journey? How advanced must its creators be? If 3I Atlas is artificial, it may not be just a message, it may be a messenger. And if it's natural, it still forces us to redefine what we thought we knew about interstellar objects. Either outcome stretches the limits of science, imagination, and humility. This is not just a comet, it's a test of our understanding of the cosmos. As of this moment, 3I Atlas is somewhere behind the sun, possibly brightening, possibly breaking, possibly doing something completely unexpected. We can't see it, We can't reach it, but soon it will emerge from the sun's glare and re-enter our line of sight. When it does, the mystery may begin to unravel or deepen further. This is the most critical moment in the life of 3I Atlas, a cosmic visitor shrouded in light, hidden during its transformation, and waiting to reveal what lies beneath its dusty veil. Whether it's a fragment of a long-dead star system, a technological relic, or an alien scout, one thing is certain: we are witnessing something extraordinary. Keep watching the skies, because the answers we seek are just beginning to emerge.